Good morning, everybody, to this lovely Thursday, where we are continuing our discussion on Roman numbers, our introduction, really. As always, can we get some confirmation in the chat that you can see and hear me? Then we can get going. Where's my glove? Oh, I need my glove. All right, we're good to go. Now, I understand if you look at the schedule, we are a little bit behind schedule. We are not ready for arithmetic just yet. We still have to make sure we understand the Roman number system completely. And there is a little bit of an issue that we need some time for. So, if you are up to speed and watched yesterday's lecture one way or another, you should notice that following the current rules of the Roman numbers, following the rules that are there to ensure that I have only one specific way of representing a quantity. If I follow those rules, then the largest number we can represent, the largest, let's say here, quantity we can represent is going to be 3,999. Because as soon as we go to one more, 3,999. As soon as we go one more, we have 4,000, and we're not allowed to have 4 of the same letter in a row. So that's a little bit of a pickle. Now, initially, they didn't even care about this because the Roman Empire, I guess, wasn't that big. They didn't need to perform calculations with larger numbers. They didn't need to pay a lot of taxes. They didn't have a lot of land, or for whatever reason, the quantities that they worked with on a daily basis didn't require that this is an issue. But eventually, of course, the Roman civilization grew and were quite successful, in part to the efficiency of their number system. It worked. It was simple enough to use. But eventually things got a little bit bigger. Numbers got bigger. Everything grows eventually. So they needed to update the system in the most efficient way possible. So their idea is really very interesting. What they came up with is to not introduce new symbols past m and make it more and more complicated, but instead they use a line above the letters to indicate multiplication by 1,000. So for example, if I wanted to represent 5,000, I would represent that with 5, and then a line over it means times 1,000. So in this way, they were able to represent larger quantities without the need to introduce more and more letters. So what we're going to do is just check if our example is ready. Back it up. I'm over here in exercise 5.3 first. Oh, I just did 5.3, number 1a. That is how efficient I am. So let us just number that appropriately. And we are already in exercise 5.3, 1a. Backwards, but still. B. So now it's just a matter of getting used to this extra rule or system or component that allows me to represent and work with larger numbers. The essence of the system doesn't change, as we'll soon see. XXV, all with a line over it. XXV line. That would be what's under the line. 25, and then the line makes it 1,000. Right? So I still look at what's under the line, then just shift it to the thousands, essentially. Okay, so with this, luckily, we're pretty much done. There isn't any new component to the Roman numbers. We're just trying to get used to it now. Your mic is not muted. Watch out for some background noise. I don't want to mute you because you're one of the few people that actually speak up. And if I mute someone on this side, I might forget to unmute them. And I don't want to do that to you. CCL with a line. CCL with a line. And then 3 M's. M, M, M. All right. So let's see. I have 250 under the line. So 250,000 and 3,000. So 253,000. Now, the nice thing is, I'll say at this stage, that we can still work in thousands in this case. The L with a line over it is 10,000s and then 100,000s. The fact that the line is going straight through and being connected, it's really just a font, a writing style. You could very easily say, well, let's do the 200,000s first. 200, line, 1,000. Then the 50,000. Then the 3,000. I'm just giving it space to indicate the separation in how I look at it. The line being connected, for our purposes, totally optional. See it as a font, as a writing style. It doesn't have to be connected. And if it helps you see the decimal places better, then don't connect it. Leave them as separate little lines. Or connect them afterwards if you like the look of it. Doesn't matter. It doesn't change how it works. All right, let's go to number 2. Now we go and convert the other direction. 582,000. A 582,000. So now you can do, I'm just going to represent 582 because I'm super comfortable with it and it's not a problem. And there we go, easy peasy. Whoops, not that one. 580,000 and then 2,000. Now here is an issue. Why not 582,000? There is now the crossover in the low thousands that I have an M to represent 1,000, yet the question here, let's say for 1,000, I have a symbol already. Or do I use an I with a line over it? Now, there's no complete record of what they did and when and how exactly it developed over time because of wars and things. Libraries burned down, the Library of Alexandria burned down, and a lot of information got lost. So no one really knows for sure, it seems, what exactly was chosen. We, however, have to make a decision so that we are consistent and we preserve the very important aspect of the number system that any quantity has only one representation. That is the most important thing. Otherwise, slowly things will fall apart. So now we have this issue around the thousands that if I don't make a decision, I'm going to have two ways to represent a number, and that is not okay. So what we are going to decide, and what I hope that they did, we don't want to lose the m, right? If we think about it, we could never have an m now. Yet the m is one of the symbols we still have today. So I believe that there was a decision made that the m is preserved and we will never have an I under a line. There's always a way to use the m instead. So there is, I lied, I apologize. There is another little rule here that we are going to follow. That is, you will never have the I letter under a line. There is always a way to use the M instead. So when I have this 2000, that doesn't appear under the line because it has its own symbol and not using I's under lines. All right. That is now the rule we're going to make, as if it definitely happened when you look back at history, though we don't really know exactly what happened. But now we've decided, so we're moving forward. So from now on, an I under a line is wrong, or a line over an I, whichever way you want to look at it. Okay. So keep that in mind, and now we are done. But we have to keep that in mind for sure. 53,000 is our next one. 53,000. So there are some things to discuss here and get used to. And I thought I left 2 lecture blocks for this discussion, but apparently only 1. But I think we're going to be okay. We're just a little behind schedule. We'll catch up very quickly. Probably Tuesday we'll catch up. So here we have 50,000 and then 3,000. That's how we're going to do it. Okay. Next one, last one. 168,000. 168,000. 100,000. 60,000. 8,000 will be 5,000 and another 3,000. Just like I can compare 8 with 5 and 3 ones. It works the same even in the thousands. So that makes me think of something else. And it's very quiet. Let me know how you feel about this discussion. If I should repeat something, if I should go faster, if you're bored, whatever it may be. When I look at 8,000 versus 8, the system looks the same. So then it's hopefully an obvious question to ask, well, what about 4,000? Because 4 at that stage was an issue and I needed new symbols essentially, and I made those subtractive pairs. So here's another question. It's not really a new rule, it's just something that needs to be clarified. If we look at 4, that was 1 less than 5. 40 was 10 less than 50. 400 was 100 less than 500. What's going to happen to 4,000? Well, it makes total sense because I can't have 4 m's. I need to have a new subtractive pair. It's going to be 1,000 before 5,000. New subtractive pair. And then, of course, 9,000 will be 1,000 less than 10,000. New subtractive pair. So when I look at a table counting some of the thousands, let's look in the book for convenience. I have 1,000, 2,000, 3,000. Okay, that's fine. Then 4,000 is a new subtractive pair. 5,000, 6,000, 7,000, 8,000. Yeah, straightforward, just additive, list more and more. 9,000 is a new subtractive pair. 10,000 has a line. 11,000, 12,000, 13,000. Yeah, it's a 10,000 and the thousands symbol. 14,000 isn't a new subtractive pair or anything. It's just 10,000 with 4,000. It's still decimal, so I do one decimal place at a time. And then I continue. 19,000 will be the 10,000s position and the 1,000s position, handled separately, and so on. Now you might think like, does the new subtractive pair issue continue? No, luckily not. We're done with the subtractive pairs because 40,000 is not a subtractive pair. 40,000 will simply be 40 with a line over it. So those aren't new subtractive pairs, just like 90,000 will be 90,000. The new subtractive pair really comes in because of my rule of no lines over i's. I need that crossover is in the low thousands, and I need special situations. I have a special situation there, special rule, new subtractive pair. So the new subtractive pair issue ends, but I should add these two to my list of subtractive pairs. Any thoughts or questions at this stage? Is it overwhelming? Is it too much? I don't know. Don't know. No one's saying a thing. Anything new is going to be overwhelming, right? That's not a reason to not do it. But hopefully it's not too much that a little time can't fix. Yeah. And it's also an inconvenient time, I guess, at this stage, because you might be thinking about the quiz, yet we're starting the next part. That never feels good. But it's just how it goes. We'll have time to catch up. That's what the weekend is for. What else would you do on a weekend? So now, technically, you could, you have no limit to the size of the number. We have no size restriction. That's right. Let's say that. We have no size restriction for our quantities anymore. That if I have, let's say, 5 million, we'll simply make that 5,000 and then times another 1,000. So you can simply stack the lines on top of each other to multiply by 1,000 and then multiply by another 1,000, essentially getting the number into 1,000,000. And of course you can continue like that. Now, we don't want to go crazy with this. I just want to note that one could do that, but when you think about it, that's not what they had in mind when they developed their number system. They just wanted to get into the thousands efficiently, so they made the line. They didn't think their numbers were ever going to be super big, right? That wasn't the situation at that stage. So the number system sort of reflects the time period. that they had a quick little band-aid solution to get deeper into the thousands. Technically, you could just repeat that, but again, too many lines over on top of each other, and it's gonna become messy again. They didn't care about that. They didn't think numbers were ever going to be that big in terms of what they needed to do. So I want to note that this is possible. You can keep doing it, but I'm not going to obsess over it. Okay. So there's some stuff in the book. Honestly, I'm happy to do exercise 5.4, but it's really not a focus in terms of a test question. If you can understand a single line, I'll do 5.5 for sure, then stacking lines really just shifts the same digits further in and make the number bigger. There's no real new insight into the number system. So see exercise 5.4 appropriately, play with it if you are interested, but I will never stack lines in a test. Okay, it'll be one line or no lines. And for that reason, we definitely want to practice by way of exercise 5.5. So feel free to skip 5.4. It's for interest's sake. I want to do 5.5 definitely so that we make sure we fit everything in and we're a little bit behind schedule. So you're not missing anything out. Okay, 5.5. Let's definitely do that. Those are appropriate test questions. So we have our two conversion directions. Of course, that's what we're going to have to do on the eventual quiz 2. Given a Roman number, well, make sure it's valid and then convert it. And the other way around. Given a decimal number, convert it back to a Roman. So this is a lot to write down. Running the risk of making a copy mistake. I guess I should do it. I'm just going to move this over so I can see it on my other screen. And I'll try and copy this without a mistake. 3x's, that's A. 3x's, a V, and they have a line. Then 3m's, a D, an X, an L, a V, and an I. Hopefully that's correct. If I make a little mistake, let's just go with the number I write down. Now, what makes this simple for me, it's my personal preference, my observation, is that this is very much decimal. So I want to separate it. There's the ones. Where are all the tens? There it is. Where are all the hundreds? It's only the D. Where are all the thousands? It's over there. And then the rest is a 10,000. Bunch of symbols. So this will then be, I'll still write it from left to right. I'm now in the 10,000s. That's 30,000. That's 38,546. But do it one decimal place at a time. Then I see that it's not really that strange. Not really that strange. Okay. And when I look at a long Roman number, then it might look intimidating, like what do I even do? But if I think of it as a decimal number, which essentially it is, then it becomes less intimidating. Okay, B. I'll copy B, it's a long one, D, C, L, X, 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 V. All of that gets a line. M, C, D, I. Okay, hopefully that's right. I think so. Okay, again, I have a 1 symbol there. I have hundreds, that's a subtractive pair. I have my thousands. I have, that's where the thousands ends. I have 10,000. Oops, not there. There. And then I have 100,000. Okay. So I have 600,000 because it's 500,000. It's 500 and another 100. That's 600 with a line as 1,000. 600,000 and 50. No, I didn't do that right, did I? Nope. Back it up. Let's pretend I did that on purpose, just to see if anyone was going to say anything, and no one said anything. My 10,000s will be 50 and the 3 tens. So I have 600,000, I have 80,000, I have 6,000, I have 401. How do we feel about that? If you have a different way of looking at it, of course, go for it. Yeah, I mean, there's a there's a reason we don't work. Our number system isn't the Roman numbers, right? It's not very efficient anymore for larger numbers. For small numbers, like a Super Bowl number, sure. But once it gets bigger, like our modern civilization requires, it loses a little bit of efficiency, right? So, oh, absolutely, absolutely. I mean, the test as well is going to be open book, so you can technically always do that, right? And we're not racing against time. The only danger really is if you can use it as confirmation, but I wouldn't have no idea how this works and then try and look it up in a test. Then I think you might run out of time. But if you're like, oh, I think this is the tens, let me just double check. I guess that's okay. Yeah, you find your sort of your comfort zone, but you'll always have those resources available. Yeah. Let's go to the next one. MCCCLXX. Those have a line over it. Then I have an M without a line. That's an ugly M. I apologize. Then I have a V with a line over it. Then I have a D, X, I, X. Whew. All right. So I'm not going to start writing this down. I'll probably make a mistake. I'm going to separate the decimal places. There I see a 9. That's a ones place. The tens place seems to be on its own. The 500 is on its own. There's a special pair, a subtractive pair for 4,000. Then I see some 10,000s. I see some 100,000s. And I see 1,000 times 1,000, which will be a million, right? Okay, so now I've broken it up. Now each space between my lines will be a decimal place. I just have to convert that one at a time. So I have 1,000 times 1,000, that's a million. Then I have 300,000. I have 70. I have a subtractive pair, which is 4,000. Then I go to the hundreds, which is 500. I have a 10 and a 9. And that's as far as we're going to go. For testing purposes, I'm not going to double up lines or anything, go further than in the millions. I think if you can handle this, then you understand how the Roman number system works in terms of conversion, and there's no need to test anything further than that, any bigger numbers. It gets a little silly because that wasn't the goal of the number system originally. Yeah. How would you get it with a double line? That was different. That was 5 million. Let me backtrack here. Let's note. 5 million, I think that was our example. Well, technically it's 5,000, right? And then 1,000. But in the case of 1 million, whoops, I'm running out of zeros here. If I don't do it with the M way, it's going to have to be 1,002 lines, and that's not allowed. So it's because of the 1 and the 2 and the 3. As soon as I go to 5, I have a new symbol, and that's allowed under the line. It's that crossover in the low, anything really, the low ones of anything, be it 1,000, be it 1 million, and so on. That's not allowed. All right, so now we have to practice the other direction, and I think we'll have seen everything we need to see. Let's get rid of that. So that's now a 2a. Now I don't know if this direction is easier or more difficult. I have the numbers in front of me. It's 86,473. It's pretty much the same, to be honest. I still look at one digit at a time, one decimal place at a time. Everything's left to right, so that's not an issue either. I read the 80,000. I convert it to a Roman number. Well, 80 is 50 and 3/10. And then I make it into the thousands. 6,000 is going to be 5,000 and another 1,000. Connect those lines there or don't. Doesn't matter to me. Maybe that M seems a little far away. Let's get nice and close. Then 400, subtractive pair. 70 is 50 with 2/10. And 3. Don't confuse my way of writing the I's as a line over it, right? It's connected there. It's a font. And there you go. But have a systematic approach so that it doesn't feel overwhelming. That's the key here. That's true for anything, right? If you do general problem solving, you do Late in the Tiger, you do anything. Have a strategy, have an approach to break it up into smaller steps so that the whole thing doesn't feel overwhelming. That's true for everything. Next up is 864,731. Now these numbers are probably already too big for what the Romans needed or wanted, but we'll stop at millions, and I think that's a good balance. 800,000, well, 800 is a 500 and some hundreds. Make it 1,000, or put it into the thousands with the line. 60,000 will be 60,000. Connect the lines, don't connect the lines. I don't care. That's not the point here. 4,000, oh, I know. That's a subtractive pair, which is 1,000 less than 5,000. 700, that's 500 and another 200. 30 is just 3 x's and 1. Systematically build the number. That is a long number, and probably part of the reason we are not using the Roman number system day to day anymore. We do see it sometimes. Page numbers, maybe some clock styles have the Roman numbers, Super Bowl numbers. So we do have a connection to it because it is underneath the surface decimal. But it's not as efficient as our number system, our decimal numbers, and we'll get to that in chapter 7. Last one, 457. And again, that is as big as I'm going to ever get. I'm not saying the test will be that big. It might not be, it's random, but it won't be bigger than the millions. So 6 million. So it's 6,000. Whoops. Yeah, 6,000. 6,000. Make it, push it deeper by another 1,000. Okay. 600. Okay, so sometimes in the millions, I'm going to have a double line. Fair enough. I'll try and avoid it in the test, so you only have single lines. I guess some higher single millions will have a little crossover. True, true. I'll try and avoid it. 600,000, 600,000. 30,000, 30, no, not 30, yeah, 30,000, yeah. 30,000. 8,000, well, that's 5,000, and another 3,000. That's sort of my crossover. Some have a line, some don't. Yeah. Just like in the millions. Some have a double line, some have a single line. Yeah. 400, subtractive pair. 50, L, 7, VII. There we go. Easy peasy. Well, no, with some practice, I guess it could be. There's no reason why it can't be. I think it's manageable. The things you have to remember is not that bad. I do want to caution you against relying too much on looking up what is L again, what is 50 again, what is this again. I think it's going to be a dangerous game. I think it's better to almost completely, if not completely, memorize the symbols and understand the system. I think the time you'll waste by having to look up stuff that you don't have memorized, you can use that time in other questions that is supposed to be more challenging. The goal here is to know it, like I'm doing it without looking. I don't have a table. I have a little piece of paper secretly on my desk. No, I know the symbols. I just write it down. I think that's better. And that's where open book tests can be dangerous, that you know you can look things up, you know you don't have to memorize anything, and then you don't really understand it completely because you didn't go through that memorization process. It's risky. It's risky. I would see the test as there is no resource. There is no open book aspect. Can I still do it? Then you can use it as a safety if you freak out in the test, like, oh, I don't know if I'm right here. Can I just look it up and double check? Sure, use the book. But use an open book, use the open book aspect in the right way. Otherwise, it could catch you out. It's a risky game. It can make things actually more difficult than if you just didn't even think that you have any option. All right, so now I will, in our remaining time, paint a picture of what is to come. Because it's important that we understand why we're doing something, even if we can't understand it completely until we look back. Okay, when it comes to arithmetic, that is, I would say, the biggest topic by far in the elementary school curriculum. By far, it's arithmetic. In one form or another, it's really all about arithmetic until maybe grade 7. It's such a big thing. Now, when we do arithmetic, for example, addition, and I have to do, let's say, 582 plus 791. Let's suppose we have to do that. I don't care what grade it is. Maybe 4. What do? We have to write it on paper, right? Pen and paper method. Well, I would maybe give myself some space here, line things up nicely. Then 2 plus 1 is 3. 8 plus 9 is 17, so it's 7, carry the 1. 1 plus 5 is 6, plus 7 is 13. So I am done. Certainly correct. The problem here is that I have done this so many times that I literally don't think about what I'm doing. I just do it. You can train a monkey to do this. He won't understand numbers very well, but he can do it. You can train, you can not train, you can program a computer, you can write some code and it'll do it. Because there's no, the method doesn't encourage understanding. The method encourages efficiency, getting to the answer as quickly as possible. That means I can do it without thinking. So then we're always going to take the easy route. If I do this 1,000 times, I'm going to naturally stop thinking because the method doesn't need me to think. However, now the same thing happens if I do, let's do 791 minus 582. For minus, I need the other one to be bigger. Same thing happens here. I've done this countless times. So I now have to go and subtract. I borrow from the 9. That becomes 11. 11 minus 2 is 9. 8 minus 8 is 0. 7 minus 5 is 2. And I'm done. I didn't think about anything I did there. There's no understanding in this. The method that I used was to find the answer, not to understand what's happening. However, the problem is, if I'm now a teacher sitting in front of little Timmy, who's doing this for the first time, sure, I can train him like a monkey. Just get the answer to me. Don't think about it. It's a waste of your time. But his brain is still developing. His number sense isn't my number sense. He doesn't understand. He doesn't have my experience. So it hurts him in the long run to train him like a robot, like a monkey. Just go through the steps and find the answer. That doesn't give him any understanding. And though many people would maybe disagree with me, that is not how we should be teaching. That is not what education is about. It's not about finding the answer at elementary school. It's about building a sense of numbers. It's building understanding. It's developing the thinking, the brain capacity. And then if one day in your job you just punch numbers into a calculator, sure, that's fine. But not little Timmy. Give him a chance. Maybe he's going to be something else that requires a lot of deep thinking and profound insight. We want to develop his brain now, and it starts with this, arithmetic. It's not always about finding the answer. So, in order for us to effectively explain and teach why this method, for example, these two, why the arithmetic method is what it is, why do I, for example, let me just my pen here tangled up. When I look at the arithmetic here, why do I say 8 plus 9 when it's not 8 plus 9? Why do I carry the 1? Little things that I completely take for granted. I don't even think about it anymore because after countless repetitions, we don't. Unfortunately, the method encourages that. Why do I say 1 plus 5 plus 7 when they're 500? It's not 5. What is happening here? Why do we do things the way we do? Do we have a number sense and understand what is happening here? Why do I put the little 1 there and call it 11? What is happening here? Why do I say 7 minus 5? It's not 7 minus 5. It's not a 7. It's 700. And all kinds of things here. Why do I borrow? What do I do with the borrowing? All these things. It's brand new to little Timmy. He has never seen this before. Okay, fair enough. Maybe when he gets to 100, he would have seen it before. But still, the concept's brand new to a large degree. For me to effectively teach, I need to really understand what I'm doing, when I'm doing it, and why I'm doing it. And I might not be at that level because I'm so used to it, I don't think about it anymore. Now suddenly when Timmy asks me, why do I say 5 minus 7? I'm like, I don't know. Just because, Timmy, just do it. No, I need to think about this beforehand, before I sit in front of a student, and I have to be ready for any question, which means I need to have complete insight into what we're doing, when, why, and everything. Now, one way to do that is to say, okay, I can't work with decimal numbers because it's too familiar, it's too straightforward. I cannot start thinking about this. I'm so used to it. Why don't we step out of our comfort zone just a little bit, change the number system? Not completely. It still has a connection to decimal numbers, but it doesn't look that familiar. And that appearance change will force me to really think about what I'm doing when I perform the arithmetic. That is going to be our goal. So we're going to do arithmetic with Roman numbers. Now we know under the surface they're still decimal, so it hasn't really changed, but it looks different, and that alone is going to force me to really think about carrying over or borrowing. What is that? What am I really doing here? And that thinking I can then take with me when I'm sitting in front of little Timmy with my familiar decimal numbers. I need to start thinking about this. And there are other ways of doing this. I don't have to start from the right. There are other ways to do this. If I didn't think about this beforehand, I'm not going to be ready for little Timmy. I'm not going to be as good a teacher as I can be. So that is why we are going to, not today, of course, tomorrow. Oh, here's my PDF. It's on the screen. I'm like, where did the PDF go? That is why the next thing after our conversion questions is to perform arithmetic in the Roman number system. And it's going to be addition, subtraction, and multiplication. Division is a little different. The method is different. It's handled differently. And we don't get the same insight as we do with the other three. So don't worry about it. Division, we're going to talk about that much later, like chapter 9. Okay. But it's important to understand why we're doing this. Not for me to keep you busy, to get better at what I ultimately will do in my job, potentially. Yes, what was your question? Yes, so we'll of course talk about that tomorrow. The point here, the only way I'm gonna actually get better is to not quote unquote cheat the objective here, but to stay in the Roman number system. Of course, I could very easily convert them, go through my no thinking method because I'm so used to it, and then convert back. Then I've learned nothing. Yeah. The goal will be to stay within that number system, to force myself to have things look strange. It's going to look strange. Yet the underlying method will not change. I will do the method you have done thousands of times. We're not changing what's happening. We're simply changing the look so that we are forced to really think about what step happens, when and why, and so on. So there's no new arithmetic method that we're teaching, that we're learning, because the one we already know is the one you'll be teaching. We just want to be really aware of what that method is saying and why it's doing what it's doing. So it's only in oh, excuse me, I got all choked up about arithmetic. It's so beautiful. I love it. The only thing we're doing is changing the appearance. We're not actually, when you scratch the surface, we're not actually learning anything new. We're just becoming more aware of what we already know. So it's a different objective. Yeah. But we will have to wait until tomorrow for that. At least I think it's tomorrow.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.